Hello everyone, and welcome to today's webinar. How does the revision of ISO 8655 affect the quality control of my pipettes? I am Kaylee Bach of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Sartorius. To learn more about our sponsor, please visit sartorius.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speakers, Joni Åke, Product Manager at Sartorius, and Axel Taube, Product Manager Services at Sartorius. Joni, Axel, you may now begin your presentation.
Thank you for the introduction. Now let's jump right into the topic. Today we are talking about ISO 8655, a brand new revision of the pipette standard. Topics for today, we have a general what is the ISO 8655 series, then we're going to talk about pipettes, and finally we're going to talk about testing and calibrating pipettes and also balances and how the requirements have changed with the new revision. So what is the ISO 8655 series? This series is called Piston Operated Volumetric Apparatus, or POVA. You might see or hear the shortened version today as well. In practical terms, it means all kinds of different devices that you use to transfer liquids, like pipettes, burettes, repeaters, etc. But for simplicity's sake, we are going to refer to POVA, or then in most of the cases just pipettes. We are focusing here on micropipettes. This standard series, it addresses the needs of manufacturers and calibration laboratories or test houses. But also it gives a very good basis for users on how to use the devices and how to take care of the devices. For manufacturers, it gives you instructions or guidelines and rules for basis of quality control, how to declare declarations of conformity, and also more general instructions, for example, product markings and user guidance. We're going to touch both of those a little bit later. And for calibration laboratories or test houses, it gives you instructions how to test pipettes. It gives you instructions what you need to account, what kind of environment you need to be in, and what kind of procedure you need to follow to test the pipettes. But then, towards the end user, the person who's actually going to use the pipette, what's in it for me? Well, if a manufacturer says and claims that they follow the standard, it's going to help you with the procurement, because you know that the products you are about to purchase are made with a certain level of quality and follow certain processes. And then it gives you the basis and guidance how to monitor the products when they are in use. So in practical terms, when to calibrate, what sort of a protocol to follow for calibration, etc. But just to be extra clear, it doesn't give you exact rules to follow. So it gives you a basis of what you can do, but it's always the responsibility for the end user, the pipette owner, to decide what kind of protocol to follow and when to calibrate the pipettes. The series consists of 9 different parts. First part is a general terminology, general requirements, and use recommendations. Second part is for pipettes. This is definitely what we're going to focus on here today. We have a separate section for pipettes only. Parts through 3 to 5 are breaths, dilators, and dispensers. And then parts 6 to 8 are different testing methods. We have 2 reference methods, part 6 and 8, and then in part 7 we have alternative methods as well. But all those part testing methods we are going to go through quite detailed in a later section as well. Then part 9 is manually operated laboratory syringes. So we have 5 parts for different kind of liquid transfer devices. All of those are piston operated, as the name suggests, and then 3 parts for testing such devices. As said, this is a brand new revision to the standard. So what's the timeline? It was already released. So 2022 revision number 2 was already released by the ISO committee. But the timeline when it becomes valid in your area or your country might vary. Different countries, even within the EU, take these in use in different times. So, for example, in France, we know that the translation is already done and it's been taken into use. But for example, Germany and Finland, it's still being prepared. I would assume that within the next 6 months, most countries have taken the new revision in use. But then again, have to highlight that you need to follow the local authorities to see what's the status. Okay, that was the general introduction. What is the standard series? Now let's take a look at the pipettes, so part 2, a little bit closer. In part 2, the standard defines and specifies metrological requirements, like maximum permissible errors for the pipettes, requirements for markings, and what kind of information a manufacturer must provide for users. Maximum permissible errors, that's quite clear. You have systematic error and random error and maximum limits that the devices must be able to fulfill. What I want to highlight here is that it's always a pipette and tip combination that such limits are given to. Then requirements for markings. So here in the picture you see that there's a manufacturer name, there's a brand name, and there's a volume. So those are just a couple of examples what you need to have in pipettes, that they need to be permanent. And then information to be provided for users. When you bring new pipette to market, you need to have a certain set of information, like how to use it, how to clean it, how to decontaminate, so how to take care of it, as well as a recommendation for calibration. This part 2 includes air displacement and positive displacement pipettes, multi-channel and single channel variants, and it always combines the tip and the instrument together. So this is a very important highlight. Let's go to the tips. So what actually changed between the first revision and the second revision is that in second revision, the language concerning tips is much more strict. In the standard, it says that the tip manufacturers shall prove that the system, including the tip, fulfills the requirement for maximum permissible errors. And this must include the variation in manufacturing as well. What does it mean in practical terms? So at the moment, previously in the market, you had a lot of specifications, but they were usually marked for pipettes. So let's say a Tacta pipette, for example, can have a maximum systematic error and maximum random error. But with the new revision of the standard, you have to separate different tips. So if you claim that you can use multiple different types of tips, for example, a standard tip and a filter tip, or a filter tip and a extended tip, for example, the manufacturer of the tip must be able to prove that the system with that particular tip and that particular pipette is going to work. Then what else changed when it comes to tips? It's much clearer now that tips are single use, meaning you can mount the tips once, but obviously you can use the mounted tip for several replicates. So you can use the tip multiple times when it's in a pipette, but when you mount it and eject it, then it's done. The tips shall not be cleaned for reuse. And then for multi-channel pipettes specifically, there is new limit for under 100 microliter volume pipette tips, how much they can vary in the nominal space. And in more practical terms, this means how bent the tips can be. There was already in the first revision limits for other types of tips, but now, especially for the smaller volume, there are more strict rules in place. And I do believe the reasoning is clear because we are moving more towards smaller micro-well plates. So the tips, especially the small tips, they need to be very straight, so you don't face any problems when hitting the wells. Then the maximum permissible errors. Even the first revision had some maximum permissible errors, but in the second revision, they made it easier for the end user. This is my view on that. In the first edition, they only gave you error limits for the nominal volume of the pipette. Let's take a case example, 100 microliter volume pipette. They would only give you limits for 100 microliters, and then you needed yourself to calculate based on the microliter value. You needed to calculate the percentage maximum error for the adjusted volume. So if you use the 100 microliter pipette in 50 microliters, you needed to use the same microliter maximum permissible errors and calculate the percentage based on that. Now the new revision gives you the limits for 100%, so the nominal volume, 50%, and the 10% as well. Multi-channel pipettes, they used to be twice the limit for single-channel pipettes, but now there is a new table just for multi-channel pipettes. And that's a welcomed addition as well. So multi-channel pipettes have their own table now. The limits are different compared to single-channel pipettes, but they are not twice the amount what they used to be, which is good for the user. And this is extremely important. These limits apply to the total system of pipette and tip. So you can't calibrate a pipette without a tip, and the tip must be specific to the calibration and what we are going to use. So let's say you have two total different tip types and you switch from one to another, then you need to recalibrate the pipette with the new tip type. Then one big addition as well was the inclusion of electronic pipettes. So electronic pipettes, they are now included in one of the annexes to the standard, which is very good because now the standard recognizes that there are multiple different pipetting modes, so how you can use the pipette. Previously, the standard only recognized forward pipetting as a standard method of testing the pipettes, which is still the case, but there was no mention of an electronic pipette and the capabilities that the electronic pipettes offer. A couple of highlights here. Speed setting for the electronic pipette can affect the results you get. Thus, the speed setting must be visible in the calibration certificate. So when you see a calibration certificate and you see that this pipette was tested in 150 and 10 microliters, you should also see the speed setting that it was used with. And then maybe the most important thing is that now there is a method for testing the multi-dispensing mode. This is something that some manufacturers have already done before, but there was no standardized way of doing it. So it was challenging to compare the performance of an electronic pipette if you check the manufacturer's data. But now there is a standardized way to doing it, and comparing different models should be a bit easier, which is really good for the user. And then user information, small collection of different factors that the manufacturer must provide. Usable volume rate. This is something you need to always have marked in the pipette. So minimum and maximum volume in case of adjustable pipette, or if it's a fixed volume pipette, then obviously it's going to be just a fixed value. Basis of adjustment, so in which temperature the pipette was adjusted to. And then maximum permissible error limits. And those can differ from the ISO standard. They can't be worse, but they can be better. List of tips that can be used with the pipette. There is no established way in a market to do this as of yet, but I would assume that there is going to be a list of the same manufacturer tips. And then suggestion for the basis of routine testing. Again, I want to highlight this is just a manufacturer's recommendation. This does not tie in the user. So user in the end is still responsible of creating the testing procedure, how often to test and how to test, etc. Then information on care, cleaning, sterilization, and upon request, the chemical compatibility. Then tip manufacturer, what information the tip manufacturer must provide. Per tip model, per tip type, manufacturer must provide an information which manufacturer and which model of pipette the tips can be used with. This is something that the standard series didn't touch earlier, because this is a brand new addition. Then chemical compatibility and sterilization data in case there are sterile tips. And then nominal volume. And here you see the difference that pipettes, they can have volume range, but tips usually have a nominal volume only. Okay, that was about the tips. And now I'd like to hand over to Axel for test and calibration.
Yeah, thank you, Joni, and welcome also from my side. In the next part, we like now to focus on test and calibration of piston-operated volumetric apparatus. Means we will have a deeper look to part 6, part 7, and part 8 of the new ISO. As it is uncomfortable to say always piston-operated volumetric apparatus, I will say in the next slides only pipettes, whereby also all the other POVAs, dispensers, burettes, and diluters are also meant. But let's start with some basics. What does calibration mean, and why is calibration of a pipette necessary at all? So each pipette, and this is independent if it's a mechanical or an electronic pipette, and of course also independent from the pipette manufacturer and the pipette model, has a small error. Means if you select, for example, a volume of 300 microliter, you will never get exactly this 300 microliter dispensed. It can be a very small deviation, but there will always be a small error. During the calibration, a comparison of the selected volume, in our example, the 300 microliter, with a known or correct volume is done. As a result of the calibration, you will see the systematic and random deviation of the pipette. In the new ISO 8655, there are now 3 different procedures described on how to perform such a pipette calibration. In part 6 and 8, reference measurement procedures are described, and in part 7, an alternative procedure is described. But why to calibrate a pipette at all? Calibration is the basis for reliable and reproducible pipetting results, and calibration confirms that a pipette works inside its small error limits. One of the main new points in the new ISO is that there are now 2 instead of 1 different reference measurement procedures included. So in the former ISO, only the gravimetric measurement procedure had been described. This gravimetric measurement procedure is now losing its unique position. Part 6 of the new ISO describes the gravimetric reference measurement procedure, and part 8 of the new ISO describes now the new photometric reference measurement procedure. The photometric procedure is given an equal status as a second reference procedure. This means the new ISO does not give any recommendation when to use which procedure. It also does not say if one procedure works better for the one or the other device. So the new ISO does not favor the one or the other procedure. Next to these 2 reference procedures in part 6 and part 8, alternative procedures are described in part 7 of the new ISO. To follow one of the reference procedures, it is necessary to perform the calibration inside very strict environmental conditions. Deviations from these strict requirements are not permitted when following part 6 or part 8. And calibrating a pipette, for example, in a normal calibration lab or in a normal lab, on the customer side, it will often be not possible to fulfill all these strict requirements that are necessary if you calibrate according to a reference measurement procedure. And therefore, the new ISO describes in part 7 alternative measurement procedures. These alternative procedures allow deviations from the strict environmental requirements within defined limits. So alternative gravimetric measurements can be performed according to part 7 of the new ISO or part 7A2 of the new ISO. Let's go on now with an important question that may come up with reference and alternative measurement procedures. So can a metrological confirmation be given under an alternative procedure? And the clear answer here is yes, a metrological confirmation can be given, but there are 2 requirements that need to be fulfilled. First, at least 10 measurements must be performed per selected volume. And second, the measurement procedure must be validated by comparison to a reference procedure. If both requirements are fulfilled, a metrological confirmation can be then also given under part 7 of the new ISO. And a second important question, the new ISO distinguishes between calibration and test. What are the differences? So a metrological confirmation can be given by both calibration and test, The only difference is that the measurement uncertainty must be given on a calibration certificate, while this is optional when doing a test. So on a test report, the measurement uncertainty is not required, while this is a must on a calibration certificate. As already said, the environmental conditions under Part 6 and 8 are very strict. The reason behind is that variations in the environmental conditions has an influence on the test and calibration results. The table shows general effects on environmental changes with distilled water and how this affects the dispensed volume. So looking first at the air temperature. When the air temperature increases, the airspace between the seal and the liquid, as well as mechanical parts, expand a little bit. As a consequence, the pipetted volume will be a little bit less. Air humidity. When the humidity increases, the airspace is more moist. Thus, less evaporation from the liquid will happen, and as a consequence, here the dispensed volume goes a little bit up. Looking to the air pressure, increases in the air pressure compresses the airspace, and the dispensed volume here will go a little bit up. And last but not least, the liquid temperature. Liquids that are colder than the air will cool down the pipettes and the airspace temporarily, and this affects that the pipetted volume goes a little bit down. The number of test points and measurements per test points are very critical, as they have a direct effect on the quality of the calibration and test results. For a variable volume pipette, at least 10 measurements at least 3 volumes are required if performing a test or a calibration under Part 6, Part 7, or Part 8 of the new ISO. This measurement type we call a 10.3 calibration, means 10 repetitions at 3 volumes. Other measurement types than the 10.3 calibration with less measurement points and less measurements per test point are only possible when performing test or calibration under Part 7A2 of the new ISO. Here it is, for example, possible to perform a 5.3 calibration, which would mean that you do only 5 measurements at 3 volumes, or a 10.2 calibration, which would mean 10 measurements at 2 volumes. But let's have now a bit deeper look on the different parts of the new ISO and their requirements. So when, first of all, looking to the Part 6 of the ISO, the following environmental conditions need to be fulfilled here. The test room temperature must be between 17 and 23 degrees. The test temperature variation from beginning of the test to the end of the test should not be more than 0.5 degrees. And this is the same for the water temperature. The water temperature shall not deviate more than 0.5 degrees from the air temperature. So if, for example, the air temperature is 21.5 degrees, the water temperature must be between 21 and 22 degrees. The test room humidity, here we do have a much stricter requirement than in the old ISO. The test room humidity must be between 45 and 80% of relative humidity. And last but not least here, the air pressure. For the air pressure, no specifications are given. It just need to be recorded during the calibration. The test conditions. A calibration under Part 6 requires at least 3 calibration points, and the 3 calibration points must be at nominal volume of the pipette, at 50% of nominal volume, and at 10% of nominal volume. As pointed out earlier, at least 10 measurements per volume are required here. And last but not least, tip change, and this is something quite new in the new ISO. The new ISO requires at least 1 tip change per measured volume. If we compare the requirements of Part 6 to the requirements under Part 7, we see the following differences that are highlighted here. The test room and water temperature, as well as the humidity, now just need to be recorded during the calibration, but there are no limits given. Same as under Part 6, the temperature shall not vary more than 0.5 degrees from beginning to the end of the test. The requirements on test points, tested volumes, and measurements per test point are exactly the same as under Part 6. When performing a test or calibration under Part 7A2, it is also possible to reduce the calibration points and to change the tested volumes, which mean that the calibration must not be performed anymore at nominal volume, 50% and 10% of nominal volume. Here you are free to choose the volume where you want to have the pipette calibrated. Here it is also possible to change the number of measurements per test point. Means less than 10 replicate measurements per test point are possible here. So working under Part 7A2 gives the user really the freedom to adapt the test conditions to his specific needs. The only requirement that is given here is that all deviations that or all points that deviate from the requirements under Part 6 must be recorded and reported. So you just need to document the changes from Part 6, but all the other things are more or less free. But let's go on with 2 more frequently asked questions. Why Part 6 and 7 of the new ISO require a tip change during the calibration? As explained earlier by Joni, the new ISO describes the pipette and the tip as one system, which means that the exchangeable parts are now seen as an integral part of the whole pipette. And therefore, calibration results are only valid for the tip type used during the calibration. So in case the pipette is used with different tip types, a separate calibration should be performed with each tip type. And in order to detect variations in the dispensing, that result from the tip and the tip quality, at least 2 tips must be used per calibrated volume. So you need to change the tip once. Means if you do, for example, here a 10.3 calibration, in total 6 tips are needed, 2 tips per volume. And the second question, is there a need to perform an as found and as left calibration, so a calibration before maintenance or repair and a calibration after maintenance and repair? And also here is the ISO, the new ISO, very clear. As the maintenance or adjustment or repair can affect the performance of the pipette, a metrological confirmation should be considered before and after maintenance, adjustment, and repair. So yes, whenever something is done with the pipette that can have an effect on the pipetting result, as found calibration should be performed. As you know, during a calibration, the result can be compared against a performance specification. 3 different performance specifications are common here. First, the ISO specs that are in the respective part of the new ISO. For example, the specifications for a pipette in part 2. The second performance specification is the manufacturer specification. These manufacturer specifications are usually much smaller than the ISO specs. As these specs are sometimes really very small, they cannot be reached under all environmental conditions. So when performing a calibration in a normal lab on the customer side, it sometimes is not possible to reach these specifications. And then, last but not least, we do have the performance specifications that are defined by users. And these are resulting normally from the process needs of the customer and the specific application. The question, of course, here is now, when following the ISO, the new ISO, is it still possible to test the pipette against manufacturer and customer tolerances, or do the calibration need to be performed always against the ISO tolerances? Yeah, to fulfill the ISO standard, a test against manufacturer and user tolerances is possible, but these specifications need to be stricter or equal to the ISO specs. If they are wider, the confirmation of the ISO standard cannot be given. With the last 2 slides, I want to come back to the balances, the most important test equipment when doing a gravimetric test or calibration of a pipette. Here we see some important changes in the new ISO 8655. If we look to the requirements of the old ISO, for example, a 6-place balance, which means a semi-micro balance, was needed to calibrate a pipette with a nominal volume of 1 to 10 microliter. With the new ISO, this changes now. If you look to the second table, with the new ISO, a 6-place balance is now needed for pipettes up to a nominal volume of 20 microliter, which means that the new ISO requires between 11 and 20 microliter a better balance than the old ISO. And this is the same, for example, for a nominal volume of 200 microliter. Up to now, a precision balance with 4 places was okay. With the new ISO, now an analytical balance with 5 places is needed here. And one additional important change is that the new ISO allows, when calibrating a multi-channel pipette of 20 microliter on a multi-channel balance, to use here an analytical balance. So here, when using a multi-channel balance, not a semi-micro balance is needed, it's okay to use analytical balance. And this, of course, is very useful as there are no multi-channel semi-micro balances in the market yet. Regarding the use of multi-channel balances, there is one very important sentence in the new ISO. A multi-channel balance can be used to measure channels in parallel. And this means the new ISO requires here a balance with several weighing cells that allow such a parallel measurement. For us, this means that systems measuring multi-channel balances, multi-channel pipettes sequential do not match with the requirements of the new ISO anymore. So here really a multi-channel balance is needed that allows to do this parallel measurement. Yeah, with this, we are at the end of our short webinar, and I'd like to open now the Q&A session.
Thank you, Joni and Axel, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. So let's get started. Our first question here is for Joni, and this question asks, can I use my pipette with tips from other manufacturers?
Hi. Yes. So in the new revision of the standard, the tip manufacturer is always responsible to ensuring and confirming that the combination works. However, if a user would like to use any third-party tips, they can do so, but I highly recommend that they verify that the combination works by calibrating the combination of the set tip and the pipette. Also, this is not a perfect solution, as there is batch-to-batch variance in tips as well as in pipettes. And if you calibrate the combination with only one batch of tips, and then you change the batch, something down the line years to come might change. So you cannot be absolutely sure that the calibration takes account all the variability in manufacturing. So that's why we would recommend to only use the combinations that have been verified by the manufacturers.
Great, thank you. Our next question here is for Axel. This question asks, why are pipettes tested and calibrated under special conditions and not in standard laboratory conditions?
Yeah, that's a question easy to answer. It's because the measurement results need to be compared or comparable if you do a calibration. So measurement results can only be compared if they are taken always under the same conditions. So if you do the testing in a common laboratory, the conditions fluctuate and can never then be compared to the measurement results in another lab. So to enable a comparison of results from different calibration laboratories, the calibration always must be taken under controlled conditions and therefore under the same and special conditions that are given in the ISO.
Great, thank you. Another question here for Joni. This question asks, how often do I have to perform calibration of my pipettes?
Yep. The standard recommends that you at least annually confirm the metrological performance. And then there is a various different recommendations from different manufacturers. So I've seen anything between 3 to 12 months to be the recommendation. But what I found out to be the best practice is to follow the risk-based approach. So depending on the risk level that you have in your application, you might have a very different calibration requirement or the interval requirements. If you need to be absolutely sure that your combination of pipette and tip delivers what, like within the limits of the devices, then obviously you need to calibrate and ensure the performance more often. And if your process has a tolerances for a little bit more error, then obviously it's not necessary to do that often. Also, I would consider the liquids that I use. For example, volatile liquids, they might damage the internal parts. For example, pipettes have seals, and seals usually are creased. So the volatile liquids might damage those. Also, some acids might damage the pipette. So in case I would handle that kind of liquids, I would probably calibrate the pipette more often. Also, I would include a proper cleaning and maintenance in that case.
Great, thank you, Joni. We're getting some great questions from our audience here, and it looks like we can try to squeeze in a few more. So we'll go ahead and proceed with this one. And Axel, this is directed towards you. Can the number of repetitions and the tested volumes be changed?
Yes, they can be changed. If you do a calibration following the ISO Part 7A2, if you follow the test or calibration according to Part 6, the repetitions need to be at least 10. So 10 or more is okay, but less than 10 will not work with the ISO Part 6 and also not with the ISO Part 7. So ISO Part 6 and 7 requires definitively 10 or more repetitions. Less repetitions are only possible if you do the calibration under Part 7A2.
Great.
Yeah, and this is maybe the same for the tested volumes. Also, the tested volumes are fixed if you do the calibration under Part 7 or Part 6. So doing so, you need to do the test at nominal volume, 50% of nominal volume and 10%. If you do a calibration under Part 7A2, also the tested volumes can be changed.
Well, thank you again, Joni and Axel, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Sartorius, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.